Well, here's what I'm going to call graphing essentials. It's kind of the basics of graphing with exponential functions. Some of the things I'm going to share with you today can be shared with other functions that are not exponential, but I'm going to focus on just y equals a number to the x. Notice what I left out of here was I did not put a number C up above that. And I did that very intentionally because I just want to focus on that growth factor and what happens to the equations and the graphs. What you see here and here are in your notes. And I just want to point out the differences between these two pictures all hinges on how big that value A is. If A is a positive number bigger than or equal to 1, so no fractions, I end up, as I read this from left to right, reading from left to right, my values here on the graph are very, very small. They get bigger very quickly as I get down towards to the right side of my graph. Whereas in this second one, it says A is less than 1. Technically, that should have said absolute value of A. In other words, if A is a fraction smaller than 1, so A might be a half or a fourth or a third or something along those lines, I get a graph where as I read it from left to right, it starts out high and gets lower as I get further to the right. Now, I've got on each of these pictures 3 key points labeled. You'll notice that those labels are identical regardless of how big A is. The first one says, oh, well, what happens if I plug in a -1? I reciprocal whatever that value of A is. Reciprocal just means take it and flip it. If x is 0, if I plug a 0 for x, I'm always going to get 1 for y. Remember, that's always going to be the case as long as there is no value out in front of that a to the x. When x is 1, well, what happens? Any number to the 1 power is just that number. So that tells me my third key point here. If I take a look, here's a picture of a graph. Can you tell what graph that is? I can tell what graph this is by simply looking at some of the key points on here. Some of those key points are going to occur right here, 0, 1. And then what happens when x is 1? Let's see if I can make that go away now. When x is 1, I'm out here. Whoop, there it is, 1, 2. Did you see that? That point here is, whoop, there to go, 1, 2. That 2, 1, 2. 2 tells me that that is the equation y equals 2 to the x. That's the equation that I've got pictured here. Now what I'm going to look at a little bit further is what happens if that number is negative. I haven't addressed that yet. If that number a is negative, when I write y equals a to the x and I happen to have a negative number out there, in other words, an example might be y equals -2 to the x. That negative takes my graph and flips it over. It flips it right across the x-axis. Remember, here's the x-axis. The graph of y equals 2 to the x goes something like this. And it's just simply flipped. It's a mirror image. Now I'm going to talk about what happens when we have a number added or subtracted to either the a to the x or just to the x. I want to take a look at what's going on here. Remember, this red graph that you see in this picture is y equals 2 to the x. Here's what happens if I just simply add 1 to that. Well, look at that. All that happened here was that this graph moved from this 0, 1 up to 0, 2. So along that x-axis is where things moved, where things changed. That green picture that you see now is y equals 2 to the x minus 1. So what happened here? It moved down. I read the x-axis in order for me to identify what's happening. That vertical shift, we call it, that vertical up and down movement. If I decided to just add or subtract to the exponent, it's a little bit tougher to read. It's a little tougher to read, and the easiest place I can tell you to look would be in the horizontal direction. Here I've got, whoops, where was that? It was at negative 1, 1, 0, 1. This point here was a, 1, 1. Did you catch that? So I have a 1, 1, negative 1. I'm making a movement in the horizontal direction. And I wrote that into your notes with some blanks for you to fill in. If a to the x, that entire function, has something added, we move up. If it has something subtracted from it, we move down. Now if I'm talking simply about the exponent, a number added to it shifts to the left, like you saw on the graph a second ago. If it has something subtracted from it, it shifts to the right, like you just saw on the graph. These are kind of the basic, the essentials of graphing to help us so that now I can take a look and see what's going to happen. So what I did on your notes, and I'm going to ask you to try this and bring it to class finished, I started on my notes by giving you a picture of the graph y equals 2 to the x. I know that that's the graph of y equals 2 to the x. It goes through 0, 1 like we would expect. When x is 1, it passes through 2. So I start with that picture. Now I'm going to take that picture and I'm going to transform it. I'm going to move it around, up, down, left, right, and I'm going to ask you to write the equations of those. So what I did first, and this is what I have listed as your part A, I gave you this picture. Now I want you to compare it to the one up above. The one up above started here, had a point here, and moved up and down from there. Now what happened to this? It's the exact same shape. It's just instead of going through 0, 1, it goes through 0, 4. Remember that the original function went through 0, 1. Now we're going through 0, 4. That's a difference of 3 spaces. So that means that it went up 3 spaces. That's the words that you're describing. And here is your equation that you're going to write. The same equation that we had up here, but now we're adding a 3 to it. So now what I want you to do is I want you to do the same thing for the part B, part C, and part D, and let's see what you can come up with to get a direction. Can you tell me what's going on here? Y equals 2 to the, and you finish that. Same thing for all of these. I've taken this original equation, 2 to the x, transformed it in some way. See what you can come up with. Bring it to class with you done tomorrow, and we'll take some time to work on some problems. Thanks.